I'm Preeti, Assistant Professor from the Department of Computer Science and Engineering. So today our topic is software models. So let us have a small recap of my previous session. Some general process framework that included 5 activities, that is communication, planning, modeling, construction, and deployment. And the other section that has already been covered are the set of umbrella activities, right? That involved project tracking, control risks management, quality assurance, configuration management, technical reviews, and the other features that were involved. And then, to start off with the process models, we have to know the process flow. So what exactly is this process flow? It is trying to describe the framework activities. What is this framework activities? It is nothing like a structure. A framework is a structure, an architecture, a template, right? So to elaborate process framework, it is nothing but it is trying to describe the framework activities that includes actions, tasks within each framework activity. And it is concentrated or organized in respect with the sequence and time. In what time is it being executed and what comes next. So this talks about the process flow. So I repeat, process flow is nothing but describing the framework activities, the actions, the tasks that are organized with respect to sequence and time. So moving to few process flows. Before I elaborate on what are process models, we have to first know what are the various process flows. How does the process actually start off and at what place does it end? And in what way is it getting implemented? So initially, as you can look at the screen, that is linear process flow. So as the term suggests, linear, it's nothing but one after the other in a proper flow manner. So looking at the diagram, we have 5 stages that were already discussed. That is the communication phase, the planning phase, the modeling phase, the construction phase, and the deployment phase. So let us look at the definition of what linear process flow is trying to tell us. It is trying to execute each of these 5 framework activities in a proper sequence, starting off with communication and ending with deployment. So what exactly involves the communication? That is, communication involves the project initiations or the requirement gathering. So I repeat, communication involves the requirement gathering and the project initiations. What are you actually trying to start off with? How are you initializing your project? So once the project has been initialized, we require some requirement specifications. So moving to the next category, that is the planning. Here, we are trying to estimate schedule, provide a proper schedule and track that schedule. That is, whenever you are trying to do some task, we give a list of works that has to be done. And we put our checkpoints, whether the first task is completed in some specific amount of time. So that is nothing but trying to schedule and track, which is done by planning. So moving to the third category, that is the modeling. This involves analysis of the activities and the designing that has to be applied on these particular set of instructions that have been stated. So the main features of this third category, the modeling, is the analysis and the designed procedures involved. Coming to the fourth activity, that is the construction. Here, the main focus is on the code. Once the code is designed, developed, we try to even test. So coding and testing is involved in this particular phase, that is the construction. Last one, the deployment. So this last one, the deployment, as the name suggests, it's the final phase where it is trying to focus on the delivery, the feedback given by the customers, or a support team which is trying to support the feedback or give any relevant statements regarding if there are any flaws given by the customer. All those things are discussed in deployment. So I repeat, in deployment, we focus on the delivery, support, and the feedback. So this is all about the linear process flow. So moving to the second process flow, that is the iterative process flow. So before we look into the definition of what is the iterative process flow, we should understand the term what is iterative. Iterative is nothing but repeating, right? If you are trying to involve in communication phase, you have stated some initiations of the project, and you also have specified the requirements gathering, right? So there are the chances of trying to repeat the things again to analyze it much better. So it's nothing but iterating. So you are iterating a phase, or you are iterating two phases at once. So if you can look at the slide which is talking about the iterative process flow definition, which says repeats one or more activities before proceeding to the next, right? Once our condition is satisfied, then we move to the next phase, right? So you are trying to repeat the flow one or more times. That is, repeat one or more activities before proceeding to the next. Before you move to the next activity or the next phase, you are trying to repeat the particular process, right? So if you can look at the diagram, you have a proper flow from communication, planning, modeling, construction, and deployment, as we have seen in the linear process flow. But when you come to this iterative process flow, you first understand the communication, where you are trying to do the process initiation and trying to get the requirements gathering, right? And then you are trying to plan out by trying to schedule the things, estimate all the plans, and then you can iterate this step. That is, again, going back from planning to communication, then again going back to planning and then communicate. It's like you are iterating. Once it is properly done, then we move to the next phase, that is the modeling. As I told you, the modeling involves the analysis and designing, right? And then again, that is iterated, then moves to the construction. Now, what are we doing in the construction? You are trying to focus on the code and trying to test that code. Okay, once that is done, again, you are trying to move to the communication phase, where you're trying to give the inputs that have been generated in the construction phase, right? And then simultaneously, the construction moves to the deployment, that is trying to give us the support, delivery, and the feedback. Moving to the next process flow, that is the evolutionary process flow. So let us have a look at the definition that is trying to tell us about. It is trying to execute activities in a circular manner, that is in a proper circular circuit, you can see, that involves all the 5 activities which are stated. Now, why are you doing this, or why are you performing that in a circular manner? Is like trying to get a complete version, that is trying to get better result in less amount of time, trying to get the efficient solutions, optimal solutions, right? Moving to, and if you can see, once you started off with communication, that involves project initiations and requirement gathering, then you are moving to planning phase. At the planning phase, you are trying to estimate the schedule and trying to track that schedule. Next, coming to modeling, you are trying to analyze and design. From there, we are moving to construction, that is trying to focus on the code, generate a code, develop the code, and trying to test that particular code. And then you are moving to the deployment. Then we were moving to the deployment. At deployment, as I told you, it is trying to give the feedback, trying to get the inputs from the support team, and trying to deliver a final product. And there you can see increment released, meaning if you want to repeat the same process again to get a proper attainment, then you will have to repeat it. Else, you can stop at the deployment. So moving further, you have parallel process flow. Now, what is this parallel process flow trying to tell us? Parallel is nothing but you are trying to execute 2 processes at one time, and then obtaining the result from the above 2 processes which have ran parallelly, and moving that to the next phase. So here, if you look at the diagram, you have construction and planning that are running in a parallel manner and leading to modeling. From modeling, you are moving to the construction and then to the deployment and then getting us the output. So let us look into the definition of it. It executes one or more activities in parallel with other activities. For example, like modeling one aspect of the software might be executed in parallel with construction of another aspect of the software. So as I told you, when you are trying to enter the communication way, trying to gather the requirements and then trying to plan it. So these two operations are parallelly in active stage, moving to the modeling. Once the modeling is completed, that is trying to design that particular model, you are moving to get the code and then get the end product. That is the deployment. So moving further, how does a framework activity change as the nature of the project changes? So this is a small kind of a scenario or a case study where a user has to think about this particular questionnaire. So what is he trying to focus? How does a framework activity, what is this framework activity? The flow that we have just seen, the communication, planning, modeling, construction, and deployment. So how does this particular framework change the nature of the project as the nature of the project changes? So what is it trying to focus on? So this questionnaire or this question can be answered if you are trying to focus on a small project or a lengthy project. If you are trying to focus on a small project, right? What do? You directly communicate with the stakeholder through a mobile phone or in other ways of communication, and then try to discuss his requirements by making a note of it and then organize whatever he has stated in a proper written statements. Those are considered as requirements. And then you can email the stakeholder for his review and approval. So these 4 points that are stated, it is suitable for a small project. So I repeat, what do we exactly do? You contact that stakeholder, right? As I told you, a stakeholder can be an employee, an investor, a businessman, a government agency, anything. So if there is a problem in the small project, so you can directly contact that stakeholder through a phone and discuss some requirements and take notes. Try to merge all the requirements stated by that stakeholder in a proper statement, organize them properly, and then you will mail the same things to the stakeholder for his review and approval. Once everything goes fine, you can start off with your process. But moving to the next category, if the project that you have considered is a complex one that involves many stakeholders, so what happens? So I repeat the questionnaire. If the project was considerably more complex with many stakeholders, so previously it was only one stakeholder where that involves a small project, and we execute the 4 things. That is, talk to him, take his requirements, list out those requirements and mail it to him, take his approval. But what if the process or the project is too tough or complex and there involves more stakeholders? So for that also, there is a set of actions that can be performed. That is the inception phase, elicitation, elaboration, negotiation, specification, and the last one is validation. Right? So coming to the first phase, that is inception. So this particular stage tries to focus on requirements gathering, where a set of questions will be asked or set of questions are brought out from a software process. That is inception phase. So I repeat, it is nothing but a requirement procedure where you are trying to gather some set of questions. Elicitation. Elicitation is nothing but trying to do some research and discover some requirements basing upon the questionnaires that were obtained from the users, customers, and other stakeholders. The third category, that is the elaboration. So what have you done in the elicitation phase? You have taken the inputs from the user, from his set of questions. You have done some research and discovered some requirements. You're trying to organize them properly in a refined manner. That is done in the third phase, that is the elaboration. So moving to the next one, negotiation. So what is happening here? The priorities of each requirement is determined. That is, what is important has to be executed first and then it is resolved. So moving to the next category, that is the specialization. So what is happening in specialization? Here, you are trying to focus on some specific products or specific software products or some programs and trying to work upon some applications that are trying to generate some particular functions in some specific environment. So specification, the name itself is specify. Specify. It's nothing but what is the product? What is the application? What are the requirements? Will that execute? So what are the relevant functions to it? All that is done in the specification phase. So the last one is the validation. So validation, as all of us know, it is like trying to check the things or trying to check whether the software product is up to the mark or not. You're trying to validate the things. So when does all these 6 scenarios come into the existence? If the project is complex and you have more number of stakeholders, then we have to follow this process of inception, elicitation, elaboration, negotiation, specification, and validation. Fine. So moving to formal techniques for assessing the software process. So how do you assess a software process? For that, you require some techniques, right? If you are given a mathematical question, there are some various formulas for you to apply and then to get a solution. So in the same way, if you want to assess some process in the software engineering, there are some techniques which are defined. They are considered to be standard techniques. So let us look at the first one, that is the standard CMMI assessment method for process improvement. So what is it stating? It states that it is giving us the 5 assessment model, which says about initiating, diagnosing, establishing, acting, and learning. So to assess a particular software process, we are given some formal techniques. They are considered to be standard techniques. So what do you mean by the standard? So let me give you an example. If you're trying to buy an electronic gadget, what are the things that you see? You see the ISO certified, right? Simply you just don't go to go and buy something, whatever you want. You see some standard, right? You're looking at that standard, you feel that, okay, it is good, so I can go with this. So in the same way, to assess a software process, we are having some formal techniques. The first one is the standard CMMI assessment method for process improvement. So if you want to improve one particular process, you have one standard that is stated, which is trying to involve initiation. That is, you are trying to take the initial inputs, trying to have a proper focus on that inputs, or trying to have a proper read on that, which is called diagnosing. Then you are trying to establishing meaning getting the better ones out of it, and then you are trying to act upon those steps and then learn from that particular things. So these are the 5 phases that are involved in standard CMMI assessment. Next, you have CMM based appraisal for internal process improvement. The first one was for process improvement, those 5 stages. Next, this is for internal process improvement. So if you want to have some internal process, what is the technique that you will follow? It is nothing but CMM based appraisal. So what is it trying to tell us about? It is trying to provide us with a technique for assessing the relative maturity of the software organization, meaning how long does this sustain? Right? So if you are having a proper study on the internal process, we can say that how long can this process or product is sustaining. So moving to the third standard, that is the SPICE. So which is trying to focus again or give us a standard set of requirements, which is trying to assess the project. The main intention of this particular standard, if you can look at the screen, it is like assessing or trying to train the organizations to first create a goal on evaluation of the efficacy of any defined software process. So this particular SPICE is trying to first ask the companies to first define a set of requirements, and the main goal is to have an evaluation of the efficacy of any desired software process. The next one is ISO 9001 2000 for software. Like this you have for various other gadgets as well. Now, what does this focus on? This is the standard applied to any organization that is trying to improve the overall quality of whatever you consider. Let it be systems, products, services. It's trying to tell us that, yes, it is completely checked and it is ready to deliver and ready to work for. And it also directly applicable to software organizations. So moving to the major discussion of today's session, that is prescriptive process models, right? What are prescriptive process models? They are defined as a set of process elements, prescribed set of process elements, and are predictable process workflows. Under this, we have few categories. That is, we will see what a waterfall model is. Under waterfall model, we will be focusing on the flow or the architecture of waterfall model, and we have V model. Then moving to the next category, that is the incremental process model. Then we have evolutionary process model. Under evolutionary process model, we focus on prototyping, spiral model. And finally, we will have concurrent models. So moving further, waterfall model. Let us start off. Before I start off, again, please have a look at the diagram, which is again the same phases, that is communication, planning, modeling, construction, and deployment. As I told you, communication is nothing but initiation of the product. Then you're trying to gather some requirements. Next, planning, where you are estimating a plan and trying to track that particular work. Model is designing part. Construction is code and generating code and testing on it. Deployment is nothing but the delivery, support, and the feedback, right? So coming to the definition of it, this is also called as classic life cycle process, right? Why is it called classic? Because major of the projects that we take up will involve waterfall model process, which states it is systematic, sequential approach to software development, right? It's a systematic, sequential approach, right? Meaning what the diagram itself is depicting. First, you are trying to collect the information, plan out a proper schedule, then design a model pertaining to that schedule, then test it. If it is good, deliver. So that is why it is called as systematic, sequential approach to software development, right? If you look at the below things, that begins with customer specifications, requirements, and their progress, right? First, you have to take the specifications, the user specifications, customer specifications. Then try to take the specifications of the requirement, then have a progress on it, then plan, model, construct, deployment until you get a completed software, right? Moving to the V model. Now, when you say about this V model, it is one of the variation that is trying to represent waterfall model, which looks as the name says V. That is, you have a top to down scenarios and bottom to up scenarios. So before we look into the representation of how V model looks like, let us talk about the relationship, right? So this V model tries to show the relationship of the quality. That is quality assurance. It is trying to provide us with the quality assurance of the relationships that happen between the communication and modeling in the early stages. That is in the initial stages when you are trying to consider communication and modeling relationship. It is trying to focus upon the quality. That is at the early stage, the V model tries to focus on this, right? So if you can look at the second point, or you can see the third point, as we move down. So what is happening as we move down in the structure of it? You are trying to focus on the basic problem requirements. That is, let me just show you the diagram. This is a diagram of the V model where you are starting from the top, that is coming down. So when you are trying to come down, you are trying to focus on the basic problem requirements, right? And when you reach the executable software, when you're trying to move up again, it is trying to focus on the programming a series of tests, right? So if you can look at this diagram, you are coming down and moving up. So whenever you are trying to coming down, you are trying to define some basic problem requirements. Next, when you are trying to move up, you're completely trying to focus on the testing. So coming back to the discussion, V model is a variation of the waterfall model. It is generally based upon the relationship between the construction and modeling phase at the early stages. As I told you, you move down to define the basic basic problem requirements, and you are moving up to do a series of testing. Why do you test? To improve the quality of that particular product, right? And moving to this particular diagram, have a look at it. Initially, you are having requirements modeling. That is nothing but you are trying to gather the requirements from the user, right? And then architectural design. Whatever the user has stated his requirements, you are trying to construct or design some model for it, right? Once that is done, you are performing the component design, meaning if you're having so many modules, each one can be taken as different tasks and each one can be designed separately. Once that is done, you are trying to generate a code for that and then execute it. Once you are landing up at the execution phase, then you would start doing testing. Now, what is this testing? So previously in our discussions, I have told you when the project is too huge, you try to break them down into different modules and each module is unit tested. That is, individual modules are tested separately, which is called unit testing. And then you are doing the integration test, merging with the component design, and then you are doing system tests that involves the design, architecture design and the requirements, and finally the acceptance testing, wherein it moves completely on the top. So now looking at the arrows, you start off with requirements modeling, architectural design, component design, code generation. These are the basic program or the problem requirements, right? And then when you move on the top, you have unit testing, right? That is linked up to the code generation and the component design. That is, you are trying to do the unit testing for the generated code and the component design that was being built. Then if you still move further, the integration testing is again associated with the component design and the architectural design, right? So when you look at this particular diagram, you should observe that when you are at the executable software, you are initially doing a bits and pieces of testing. That is the unit testing linked up to the code generation. As you are moving from bottom to top, the testing phases are increasing, where you land up at the acceptance test, right? So this is about V model, and we have some more things to be discussed about what happens if the waterfall model sometimes fail, right? So what does this mean? When does the waterfall model fail? So when you consider some real projects, right, follow the sequential flow that model proposes. So generally, when you say you are executing a project, you are following some predefined steps. It's nothing but the sequential flow that is followed by a real project, right? So although the linear model can accommodate iteration, it does so indirectly, right? As a result, changes can cause confusion as the project team proceeds. So what is the first flaw, or why does the waterfall model generally fail? It says that you are trying to have some specifications already defined for a real project that involves iteration and some kind of linear flow, right? So what that happens if you're trying to suddenly change something intermediately, or in the internal stuff, you're trying to change something that leads some kind of confusion for the people who are working in that team presently. So that is where sometimes waterfall model can fail. Or it is often difficult for the customers to state all the requirements explicitly. Meaning, if I give some work to some person, he states me some 10 statements saying that I will work accordingly. But sometimes in the process, he may not do the third step as he has stated before, basing upon the situations, the time constraints, the cost, all these things. So it is like sometimes it is difficult for the customer to state all the requirements explicitly. So the waterfall model requires this and has difficult time to accommodate all these natural things already stated and existing when you are trying to do the process, right? And next, the customer needs to have patience, meaning as the time proceeds, you have to change some working versions of it, and you have to even change something intermediate. Like it means to say that the customer should not be fixed to whatever it has been stated, and it has to be executed in this manner. There are so many changes that occurs, and the customer also has to go along with the changes, right? Now moving to the next one, that is the incremental process model. Now what is this incremental process model trying to say? It is nothing but it will deliver in a series of releases called increments, right? Suppose I have some work given to me. Suppose I am trying to paint a image, right? Paint some kind of, or I'm trying to draw some image. So I cannot draw everything, right? If I want to draw a scenery, I cannot draw everything at once. First I draw the outline, and then I try to fill that outline with different content, and so on. That is nothing but you are trying to execute in proper series, and those series are called as increments, right? Next, what is happening? You are trying to do them in a linear and a parallel process flow. You're trying to combine the elements which are stated in a linear and a parallel process flow, right? And the model applies linear sequences in a surprising manner as the calendar time progresses. Meaning, what is this stating? The model applies linear sequences in a surprising manner. So sometimes without the intention of the particular person involved in that particular process, whatever has been stated, it goes automatically, right? Basing upon the time that you have specified in the calendar, it takes in and tries to execute. Next, each linear sequence produces deliverable increments. That is, every module that you have taken is actually having some series of elements, and that is executed in one increment, second increment, third increment. Like for example, if you are taking a word processing software, at the first increment, what does it do? It tries to give us a basic file management. In the second one, what does it do? It is trying to edit and document. And in the third one, it is trying to check the grammar. And in the fourth one, it is trying to make a proper layout, and so on. Like that is the working of incremental process goes, right? Next, you have something over here which states your customer demands delivery by date, right? Meaning what? You are trying to do some, arrange some party or something, you have planned out everything and you want everything to be delivered on time. That sometimes is impossible to be met, right? And suggest delivering one or more increments by that date. So what is this incremental process trying to focus? The entire project is trying to be broken down into bits and pieces, and you're trying to focus on that each bit, considering it as an increment. There are chances of us to execute one increment, but the second might not be done today, the second you're doing it tomorrow, and later you can merge all these things and give us an output, right? So this states that your customer demands delivery by date, which is not possible. So what do? You're trying to suggest delivering one or more increments by the date, saying that this will be executed, you can have a check on it. Second one, you can have a check on it. Later, the entire one is done one after the other. So this incremental process, what exactly is stated here in this cloud, you can see. Next, there are some other things focused on what exactly happens in the first increment. That is, you are trying to focus on the core product, trying to get the requirements, trying to address, and any extra features also you will do it. Next, plan is being done in this next increment. As you can see in the fourth point, plan is developed for the next increment. And then you have, it is trying to meet the needs of the customer, right? And next you are trying to, the process is repeated. So this is a basic process where you are trying to focus on the core product. Core product is having some requirements. You are trying to address it. If additional features are required, then you will plan it and then you will execute it. If needed, you will try to repeat this process. That is why it is called as incremental process, right? Now, looking at the diagram, you have the 5 phases which have already been discussed: communication, planning, modeling, construction, and deployment. So the x-axis takes care of the calendar time, that is in what way you have scheduled, and the left side, it is trying to show you the functionality and features. So this diagram depicts that an entire project can be broken down, and each increment 1, increment 2, so on to increment n. So at the first increment, you are trying to deliver whatever has been stated in the first module. Then increment 2, the second part, deliver it. Third part, deliver it. At the end, you are trying to merge all of these things together. So this is a diagram that depicts the incremental process model. Then we have something called evolutionary process model. That is the next category of the discussion, which says that it is a complete version of the software with each iteration. What does this mean? Evolutionary process model produce an increasingly more complete version, meaning previously incremented, what did we say? It is trying to break down, trying to focus on each piece and deliver that increment, right? Here, it is trying to give us a complete version of the software in the other terms, right? And prototyping, you have something called prototyping over here. Now, what is this prototype trying to focus? It is nothing but a customer is trying to define set of objectives, but does not identify the detailed requirements for functions and features. So in simple terms, you can say that it is an early sample model or a release of a product built to test. So prototyping is nothing but it's a simple early process only for the testing purpose. You are not completely focusing on the functions and the features, right? Moving to the next point in the prototyping, which states that the developer may be unsure of the efficiency of an algorithm. Unsure of efficiency because you have not given a clear-cut picture. You are just given a sample model, which is in its early stages, right? In all these kinds of scenarios, prototyping is a best paradigm. How can this sample or an early or a simple model be a best approach? So let us have a look at it, right? So when you look at this particular evolutionary process model, again, you start off with communication, quick plan, modeling the quick design, constructing and deployment. So looking at the right side of the slide, which states when your customer has a legitimate need, but is clueless about the details, develop a prototype as a first step. Meaning what? I, as an employee or heading some office, software company, right? I have to give work to my co-employees or my team leaders, or team leaders in turn tell their team members. There, when you are giving that discussion, when the discussion goes on, like that particular person, meaning they are working for the customers, when your customer has a legitimate need, when he wants something or when he's expecting something from the company, you can give him some details. Those basic details is like trying to develop a prototype in the first step. That is, give them some idea of how your model looks like, or at the early stages, how do you elaborate that particular model? So what are the other things it is stating? You meet with other stakeholders to define the overall objectives of the software. So what did we initially say? Define a prototype first. Give them a simple model. Then try to have focus on all the stakeholders by knowing their all objectives. And then plan all of them. Then focus on the design, which will again lead to some feedbacks given by the stakeholders, and again tuning them, again providing them the feedback, right? Prototype is tuned to satisfy the needs, right? At every stage, you are trying to give them a prototype that is nothing but trying to give them some simple model, right? Once that is generated, you try sit and take all the objectives from all the stakeholders, plan, design, give them the feedback, and do, right? Now, there was actually a case study, you can say, which is stating that prototyping can be problematic. So why is it so? Both the stakeholders and the software engineers like the prototyping paradigm. What is this prototyping paradigm? Just trying to create a small model in bits and pieces, right? So obviously the stakeholders and the software engineers like it, saying that, okay, this work, you have done it in this way, good. Do the second work in this way. So it is easily interactable. That is why it is good. Next, users get a feel of the actual system. Obviously, when I say please execute this. You're giving him the feedback then and there itself. That is, you're getting the feel. You're getting a good feel of how does your system actually work. Next, but prototyping can be problematic. See, we have said it is a good approach, but there are some situations where you can feel that it is creating a problem. So what are they? It is nothing but there are some stakeholders who tell that it has to be finished in less amount of time. So stakeholders see what happens to the working version of the software, unaware that the prototype is held together randomly, unaware that the rush to get it working haven't considered the overall quality, right? So when you say, when does it become problematic? When there is a force from the stakeholders trying to ask us to finish off, rush off the things, and then there we don't attain a good software quality. Next, when that is happening, you will not be able to fix most of the errors. Okay. And then you can also say that as a software engineer, you often make implementation compromises, right? Saying that the internal structures, that is the software specifications, inappropriate operating systems. Sometimes it's stating that an inappropriate operating systems or programming languages may be used simply because it is available and known. And inefficient algorithms may be implemented, supply to demonstrate the capability. So in short, let me tell you, prototyping is good. They have said that is the approach of prototyping is good because you're trying to create a simple model, discuss with the stakeholders and give them the output then and there itself. But sometimes it may be problematic when there is a force from the users, from the end user saying that to execute it fast, right? Without having a proper knowledge about the software requirements. This means that, right? And finally, moving to the spiral model. It is an evolutionary software process model that is trying to merge or couples the iterative nature of prototyping. That is nothing but providing a potential rapid development, right? It involves this. It involves the risk development process model, which is trying to guide multi-stakeholders. So this particular spiral model is another evolutionary software model where it involves risk-driven process. That is, you have multi-stakeholders involved, right? And it has two main features. One is incrementally growing a systems degree. Next, you are trying to set some anchor point milestones. That is, at this point, this has to be delivered or executed. Those are called milestones or anchor points. Looking at the diagram, you have again the communication, planning, modeling, construction, and deployment. So you are starting, it is like moving in the spiral way. That is why it is termed as spiral model. Now, what does it telling you in simple terms? This can be adapted to apply throughout the entire life cycle of an application, meaning it is a repetitive process completely you can do until all the processes are completed. That is life cycle of an application. Until the entire application is executed, you can go through all these phases from the concept development to the maintenance, right? And what does it state? Each framework activities is trying to represent one segment. So what is this one segment? If you can look at the diagram, you have a V-cut or a segment, right? You have a cake and you divide them into different sections which are called segment. One segment given to communication, planning, modeling. So this particular V-shaped thing that you can see in the diagram is called a segment, right? And as you see, as the process begins, what does the software team do? It is trying to perform activities that are implied by the circuit around the spiral. That is, in a spiral manner, it moves in a clockwise direction, which is starting from the center. And risk is also considered at every stage, at every revolution. And we have stated anchor points or anchor point milestones, which is nothing but trying to combine work products and the conditions which are achieved along the path of the spiral way at each segment again, right? So the first circuit will result in the development, and when you are moving into the subsequent passes, it is trying to define a prototype, and then each pass will generate a result and you're trying to adjust those according to the plan. And then feedback is derived, And finally, the project manager is trying to plan the iterations. How many are required, right? So this is all about the spiral model. In depth, it is talking about how many iterations you can take, what has happened in the first circuit, that is concept development, how many times you can iterate, and how well does the project come in terms of product enhancement project, that is given by the project manager. So finally, we have concurrent modules. Now, what is this concurrent modules? Sometimes called as concurrent engineering, which is trying to allow software team to represent iterative and concurrent elements. So this is comprising of both iterative and concurrent elements. This is more appropriate for product engineering projects. So generally, when you have some product engineering projects, this concurrent models come into more existence because you're trying to focus on different engineering streams. So looking at the diagrams here, we focus on something called modeling and activity, right? So initially you are in the inactive stage and then you move to underdeveloped stage. That is whenever you are trying to start off an activity or represent the state of the activity. Then when it is an undeveloped, you wait, which is called the awaiting stage, and then you perform some revisions to it. Then if it is under review, it is baseline and done. So this is repeated like this. This is called concurrent model, which is again providing us a semantic representation of software engineering within modeling activity, right? So moving to what exactly happens, you have modeling at the first phase, which is trying to focus on the activities, and then you have communication or construction. Then you have activities that exists concurrently but reside in different states, meaning you can have so many states, and those states, if they are an inactive, they are supposed to be in a waiting stage, right? As you can look at the example, below that example, the fourth point, if you can see the modeling activity which existed in the inactive state while initial communications, which is called, it is in the under development state. Then when the customer indicates the changes, then it is trying to move to the awaiting state, right? From there, you are triggering some series of actions stated by the customer. Then you are trying to test them in the early stages, analyze the correlations between them, and then it moves on, right? So that is the phases that involves in the concurrent model processing. And coming to the end of our discussion, we have specialized process models, which are divided into component-based, formal methods, and object-oriented software development. So what is specialized process models, or within that we have component-based development, right? So here, the first thing is, what is the application is the first thing that you have to know. What are the issues relating to it? And then how are you trying to accommodate whatever you have stated? And then trying to integrate them into an architecture, trying to combine them, then testing and ensuring their functionality. So this is about the component-based development, that is trying to know about the domains of the particular application, knowing their questionnaires, trying to know the issues, knowing the issues, how can they be designed and how can they form an architecture, how do you test them. Next, moving to the second category of the specialized process models, they are the formal methods. So what are these formal methods? They are trying to tell that it is trying to provide us with a defect-free software, that is no bugs at all. So what does this do? It's quite time-consuming and expensive, right? And we also say that software developers have the necessary background to apply these methods. It is difficult to use these models, right? Coming to the next category, that is the aspect-oriented software development. In short, it is termed as AOSD. It is trying to define aspects that express customer concerns that cut across multiple system functions features. So as the name suggests, aspect-oriented software development. It is trying to express concerns of different customers on a multi-based system, and it involves various multiple function features and information, right? And it also finally states that it's a new software engineering paradigm which is trying to focus on defining, specifying, designing, constructing, and uh, giving us the final aspects of this. So these are the three types of specialized process models. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.